Okay, now let's look at equation of a progressive wave. The general wave equation for a sinusoidal progressive wave. So we have two equations. The first one, when wave move to the right. And second, when you have wave move to the left. So when your wave move positive x direction, which is to the right, formula will be A sine omega t minus kx. A sine omega t minus. This minus, basically minus or plus here is where your wave comes from. When your wave travels to the right, basically it comes from the left. So because it comes from left, so that's why you will have a negative here. When your wave move to the left. Now wave move to the left, so where does it comes from? This wave comes from a positive direction. So you have omega t plus kx. Based on this information, what do you need to know is the amplitude, omega, and k. T and x is the variable. Omega comes from a formula of 2 pi f, where you have your omega is equals to 2 pi f or 2 pi over period. No? Next is your k. K is 2 pi over lambda. Thus, to complete this equation, you should know what is your amplitude, your omega, and your k. So where y is the displacement of the particle, a is amplitude, omega is angular frequency, k wave number, and t is the time taken. Next, vibrational velocity and wave propagation velocity. What is the difference between vibrational velocity and wave propagation velocity? Vibrational velocity is the particle vibrational. Again, as you know, this wave is made of particles, where your particles goes up and down producing wave. So there are two types of velocity. So as you know, particle goes up and down producing wave. So as particle goes up and down, that is what we call vibrational velocity. And the wave, the particles made, that is wave propagation velocity. So the first one, particle vibrational velocity. To calculate velocity, it is a differentiate of displacement. Differentiate displacement, you'll get velocity. So from a general equations of displacement, y equals to a sine omega t plus minus kx, we're going to differentiate this equation with respect to t. Recall back, when you differentiate your sine x, you will get cos x. When you differentiate sine 2x, you will get 2 cos 2x. So now, apply this concept into our equations of a sine omega t plus minus kx, differentiate with respect to t. We will have a formula of velocity is equals to a omega cos omega t kx. Okay, this plus minus indicates that this equations applicable for both positive and negative. When you have a positive plus kx, so your formula will be a omega cos omega t plus kx. If you have a minus kx, so your velocity will be a omega cos omega t minus kx. Particle velocity Vy is not constant and varies with time. So this is equations of particle vibrational velocity. Okay. Next, a transverse wave on a string is moving to the right with a constant speed. This is what we call wave propagation velocity. A string particle move up and down, and the speed of the particle change from time to time as the wave passes. How to calculate wave propagation velocity? Wave propagation velocity defined as the distance traveled by wave profile per unit time. So the formula of V is equals to distance per time. So in this case here, for a complete one oscillation, the distance will be lambda and time will be period. This is for one complete oscillation. And you can substitute your period with frequency where you have your T is equals to 1 over F. So formula can also be represented as V equals to lambda F. The SI unit is meter per second, and this one here, the value of wave speed is constant compared with vibrational velocity. Particle velocity is varies with time. Last part of this 10.1 is the displacement graph of the wave. So again, we have two types of graph. The first one is displacement against time, and the second one will be displacement against y against x. So the first one, the graph shows the displacement of any one particle at any particular distance. For example, consider the equation of the wave a sine omega t minus kx, minus because your wave traveling to the right. When x equals to 0, so this one here will give you 0. So equation of wave will be a sine omega t. How to plot? Now, this is amplitude. This value will be here, a omega. So you can determine what is your period from omega, where you have omega equals to 2 pi over t. So the value of one complete oscillation. The graph, shape of the graph is based on whether it is a sine or a cos graph. So this is a sine graph, amplitude, and from angular frequency, you can determine what is the period. Then this is a plot of y against t graph. Second, when you have a graph of displacement against distance, graph shows the displacement of particle at any time t. For example, you have t equals to 0. So your formula will be a sine, this part here 0, so negative kx. You move the negative, your equation will be y equals to negative a sine kx. What does this mean? So the graph of y against x, as our t equals to 0, will be a negative sine graph. So from here, shape of the graph is a negative sine graph. Then this value here will give you the amplitude. And now when you have kx, based on what we have discussed just now, k is equals to 2 pi over lambda. So from value of k here, you can determine what is your wavelength. Now this is the value of your wavelength, one complete cycle or one complete oscillation. When you have t is equals to 0, you can plot a graph of y against x. So that is basically for 10.1, where you have covered all these subtopic or all the learning outcomes which we have discussed. So the first one is the definition of wavelength and wave number, and then discuss particle vibrational velocity and wave propagation velocity, and the last one is graph of displacement against time, where you have your displacement against time graph, where you have your x equals to 0, or displacement against distance, where you have your t equals to 0. Particle vibrational velocity, Vy is negative a omega cos omega t plus minus kx. Wave propagation V equals to f lambda. And then define wavelength and wave number k. So that is all for lesson 10. Thank you.